In this video, we will generate a few more type 2 groups. We will generate those groups which can be represented as a combination of a mirror plane perpendicular to an n-fold axis, and we will see what happens with n is equal to 2, 3, 4 and 6. So, this is my n-fold axis, and now what I do is to put a mirror plane not parallel as I had done it in the previous part of this series, but this time perpendicular to the n-fold axis. The Hermann-Morgan notation for these, which is also the international notation, is that if you take a two-fold axis and put a perpendicular mirror, then it is shown as a fraction 2 by m. Similarly, we can have 3 by m, 4 by m and 6 by m. The Schoenflies notation is C2H, C3H, C4H and C6H. But what we will see that 3 by m actually becomes same thing as 6 bar. So, there is no such notation 3 by m in Hermann-Morgan notation. It is considered to be 6 bar, which we have already met when we were discussing the monoaxial roto-inversion groups. This was discussed in part 6. However, Schoenflies keeps the notation C3H. So, what is considered as a 6 bar point group or a 6 bar axis is considered as a threefold axis with a horizontal mirror plane. So, this H of Schoenflies now represents horizontal mirror. So, a perpendicular mirror plane, since the axis is considered to be vertical, so the mirror plane becomes horizontal in Schoenflies way of looking at it. So, let us generate these groups. So, a mirror plane perpendicular to two-fold 2 by m or C2H in Schoenflies notation, and these groups are also written as in a linear way as 2 by m. So, we can use 2 by m, 4 by m or 6 by m also in the international notation. So, a style of writing can be different, just like when writing fractions we can write either in either way, we can in the terms of point group also we can write it in either way. So, let us again start with the point group 2, which has two operations, two general positions, but we want to add a horizontal mirror. Horizontal mirror coincides with my primitive, and it will reflect these two general positions into reflected position. So, the handedness will change. So, from black we will now use red, and since these positions are represented as dots, are representing positions above the equatorial plane, I will now and reflection will take them below the equatorial plane. So, now I am using open circle. So, red open circle to represent the reflected configuration. 1 and 2 black dots correspond to the operation 1 and 2 of the original point group 2, but now we have two red open circles also, and that can be designated, this one can be designated as M. But what about this? So, you can see that that is an object of changed handedness and on the other side of this two-fold axis. So, if I relate my original black dot to this red circle, this is related by actually an inversion center on the two-fold axis. So, this operation is actually inversion. So, it is easy to write the group now. 2 by m group which has 4 operations, 1, 2, m and 1 bar. Since there is only one mirror plane which is perpendicular to the twofold, there is no need to give subscripts to define their orientation, but still if we wish to do that, we can write this as 2 001, that is a twofold along the z axis, and M001, that is a mirror plane perpendicular to the z axis. A group of order 4 with 2 type 1 operations and 2 type 2 operations. So, now let us consider the case of threefold. I have the point group 3 with 3 operations, 1 3 plus and 3 minus, and the corresponding 3 general positions. I want to develop a group by placing a mirror plane perpendicular to this threefold. So, I place a mirror plane along the equatorial plane. So, this horizontal plane or the equatorial plane now becomes mirror. It reflects these original objects which were the right handed object above the plane into reflected counterparts which are left handed object below the plane. So, below represented by open circle, and the handedness change is shown by red. So, now I have a group of 6, I have a set of 6 general positions. So, correspondingly there will be group of 6 operations. What are these 6 operations? So, let us see. So, I am trying to write 3 by m, which is 1 3 plus 3 minus, and I have an m, but I have 2 more operations. So, m can be, this general position is m, but what are these general positions? So, if we look at that, and if you recall what we have already said, that 3 by m is going to become 6 bar. So, these two are actually related to the original point 1 by 6 bar. So, if I start with 1, rotate by 60°, that is a 6-fold rotation, and then invert. So, handedness will change from black to red, position will go from above the equatorial plane to below the equatorial plane, and I will end up there. So, this red circle here is nothing but 6 bar plus, and this one you can convince yourself will become 6 bar minus. So, the 2 additional operation in this group are nothing but 6 bar plus and 6 bar minus, and these were exactly the operations you will recall from the group 6 bar. So, that is why in international convention it was decided not to use 3 by m, but to use 6 bar as designation for this group, which we have already covered. So, 3 by m becomes 6 bar. Although Schoenflies notation uses this 3 by m construction for this group, and so the Schoenflies notation is still C3H. So, I am crossing out 3 by m, do not use 3 by m as the designation. you can think of it as 3 by m, threefold axis with a perpendicular mirror plane, but you should call it 6 bar because that is the convention. Now, we come to the fourfold axis. We wish to place a perpendicular mirror. Again, the 4 general position of the fourfold axis, and they will reflect into 4 more position of change handedness below the plane. So, you have 8 points, and you can see here in this case that the original blue right handed object is converting into this red left handed object below the plane, and that is again an operation of inversion as we had seen in one of the previous cases. So, this is 1 bar. So, which means I can write the group operations using this fact. So, the group 4 by m obviously has the fourfold axis. So, it is 4 plus 2 and 4 minus, but now it will also have 4 type 2 operations. One of them is m, one of them is also 1 bar, we have seen here, and if 1 bar is there and 4 is there, so the group operation requires combination of 4 plus and 1 bar, and you know that 4 plus and 1 bar should give you 4 bar plus, and 4 minus and 1 bar should give you 4 bar minus. So, the 8 operations of this group, 4 type 1 and 4 type 2 are these. Coming to our final group, 6 by m. Now, you have enough practice in this kind of process. So, you can just put your horizontal mirror to a 6-fold axis, and as usual in the previous cases, the number of equivalent points double up and the number of operations will also double. So, now you have 6 operations of type 1. So, 6 by m, 6 operations of type 1 as for the 6-fold. So, 6 plus 3 plus 2, 3 minus and 6 minus, and you can see here also you generate a center of inversion because this point related to this circle is by inversion, and mirror anyway you had added. So, you have a mirror, you have an inversion center, and just like I wrote for the 4 by m case, if you have 1 bar, so you should have combination of 6 plus and 1 bar, that is nothing but 6 bar plus. Similarly, you will have 3 bar plus, 3 bar minus, 6 bar minus. So, 6 operations of type 2, 6 operations of type 1. You may notice that when combining 1 bar with these rotations, I combined 6 plus to give 6 bar plus, 3 plus to give 3 bar minus, but I did not combine it with 2. Why not? Well, you can combine, that will give you 2 bar, and that 2 bar is exactly, as you know, is m. 2 bar is a mirror plane, which I have already noted. So, actually 2 is also combined with 1 bar. So, this group gives us a group of order 12. Thank you very much.